Alright, so this is a video on topic 10, graphing sine and cosine functions. In order to understand how we can graph the functions, we have to understand the general sine function. So we have a few values here, a, b, c, and d. A affects the amplitude of the curve, b affects the period or length of the curve, we'll go into that later, c affects the horizontal translation, and d affects the vertical translation. I have the general sine curve drawn out here. Sorry, I'm filming on an iPad and I'm like really confused about how to hold this. Okay, so we can see that the amplitude of a sine curve is 1 because we can see that from the principal axis to the highest point of the curve, which is here, it goes to 1. So our amplitude is 1. So A on that general sine function is 1. So B is our period, and we can see that our period here is 2 pi, because in order to do one full sine curve, it goes the distance of 2 pi or 360 degrees. Just think of it as a full revolution on your unit circle. So I would have drawn out more revolutions, except I felt like it would be easier to understand if I just had one drawn out, but if we were to draw another one, we would start here and then just draw the same thing, and it would go to 4 pi, and it would continue like that. Now this sine curve is not horizontally or vertically translated, it's just the general sine function. So I have here a horizontal translation and a vertical translation, and if you want to look at this in your book, it is example 3 on page 241. So the horizontal translation for A is to the right by 1 unit. So the original sine wave is the dotted line, the dotted curve, and the translated version is the solid curve. And you can see in the equation that it has been translated to the right by 1 unit just by seeing that 1 was subtracted from, 1 was subtracted in the position, oops, wrong way, in the position of C. So C here, which affects horizontal translation, is -1. If you want to move to the right, you subtract 1, and if you want to move to the left, you add 1. And then there is, for B, a vertical translation downward by 1 unit. And again, the dotted line is the regular sine curve, and the solid line is the translated version. So here you can see that 1 took the place of D, which affects vertical translation, and -1 was used to take the curve downwards 1 unit, and if we had wanted to take the curve upwards by 1 unit, we would have added 1. So basically that's all about sine curves. Now just briefly to discuss the cosine curve, which is very similar to the sine curve. It has the same amplitude as the sine curve, the standard sine curve, excuse me, and it has the same period too. It goes 2 pi or 360 degrees, and its amplitude is 1. The only difference is that it's basically positioned differently. So here we have the sine curve and the cosine curve. You can see that the highest point on the cosine curve is when it's at pi over 2. Meanwhile, the highest point at the cosine curve is at 0 or 2 pi. Basically, I just think of the cosine curve as the sine curve, the horizontally translated to the left pi over 2. So really, it's the same curve, it's just moved slightly, and when you're actually using it in an equation, you would write sine or cosine depending on the curve. So I hope that all makes sense. I took a video of an example, and I tried to take a video of the example after this explanation, but it didn't work out very well because I wasn't able to explain it well, so I actually have it here, and I'm just going to show you how I did this example. We looked at this earlier on in the year, but I think that it's still very relevant, so I'm just gonna hold it up here and you can watch it. This is an example on page, oh, you'll see. So this is how to do number 5 on page 245, chapter 10, section, what, C? Yeah, C, section C. So we looked at this problem originally a while ago, but we are coming back to it again. So I wrote down some of the important information that's given to us. 1 revolution takes 100 seconds to complete. The radius of the wheel is 10 meters, and the bottom of the wheel is 2 meters above the ground. So in order to solve A, I realized that the full height of the sine graph is going to be the radius times 2. So the radius times 2 was 20, and then I divided that by 2, which equals 10. Now, I went about that in a roundabout way. You really just know the amplitude, A, by looking at the radius. So, yeah, but, you can do it in my weird roundabout way if you want to. So to find B, which is period, all we had to do was look at how long our revolution is, which is 100 seconds, and then put that in as our B value in the denominator of the equation 2 pi over B. And we know that the sine curve is 100 seconds because it's the same as 1 revolution. Basically, this lovely little circle that we have here is the same thing as a sine wave, just in the form of a circle. Like I drew it out here because my brain wanted to visualize it really badly. So this is like, if you just took this and flipped it over, you got a little circle. So this thing is the same thing as 1 revolution on a circle. So all we did was plugged 100 into the equation and got pi over 50. And I checked that in the book, so it's right. So to find C, which is the horizontal translation, we just needed to figure out where the first middle point is, and then after the middle point, it needs to go up. So I did this by looking at the circle. So we have the minimum here, so we can't start our sine wave here because then our sine wave would just go like this. And that's not what a sine wave looks like. A sine wave looks like this. I hope that makes sense. Makes sense in my brain. So here, when we're a quarter way through the wheel, the sine wave goes like this. So because it goes up like this, and then it goes down, as you can see in the rest of the wheel, and then it goes up again a little bit. So it goes up, down, and then up a little bit again. So we're just looking at this point right here as where our sine wave starts. And in order to find that, we took the time of 1 revolution and divided it by 4 and got 25 seconds. So I'm actually going to mark that right there because I like that and I like having it drawn out, even though it doesn't say we need to have it drawn out. So that's 25 seconds. So D, ignore the scribbles, I messed it up in the first place. So for D, we need to find the vertical translation, and that was actually very easy. As the problem says, the bottom of the wheel is 2 meters above the ground. So all we had to do was add 2, which is the height of the wheel at its minimum above the ground, and then add the radius, because the radius is 1/2 of the total height of the thing, also known as the amplitude. So we just had to add 2 and 10, and we got 12. So I'm going to write our thingy out here. Can you see this at all? Maybe. I'm looking on 2 different things. I'm looking on my paper and I'm also looking at my phone. So A equals 10. 10 sine of B, which we found to be pi over 50. And X minus 25 seconds. And then we add 12, which is our D value. And this is our answer. I hope that made sense.
All right, so that was the best explanation that I could provide of that problem, and I hope this video was helpful.